So, I'm talking about the example of the two firemen. I've sometimes thought I should call it the paradox of the two firemen. People love paradoxes. Everybody has their own solution to any paradox and so on. And this is a kind of a sequel to a paper that's in the Journal of Philosophical Logic, Contradictory Information, Too Much of a Good Thing. And I presented that at a previous one of these workshops. And I want to thank Amos for having me at a second one, and also just say, you know, what a great pleasure it is to be at this workshop. It's interesting topics, very multidisciplinary, which is my nature, and nice people. So I want to give this example of the two firemen, and it could be seen as motivating the formal apparatus of the earlier paper. I'm going to actually end the talk with a quick review of the earlier paper, but I want to start with something that's sort of more neutral, as it were, more data, not interpreted data yet. And I want to argue that contradictory information can sometimes be better than nothing. And rephrasing this to match the theme of the workshop, contradictory information can sometimes have value. Now, Hillel and Carnap, back in '53, wrote, "It might perhaps at first seem strange that a contradictory sentence, hence one which no ideal receiver would accept, is regarded as carrying with it the most inclusive information. A self-contradictory sentence asserts too much. It's too informative to be true. Too much of a good thing." Now, Luciano Ferretti, who wants what he calls a strong semantic theory of information that avoid what he labels the Bar-Hillel-Carnap paradox, he says contradiction contains zero information. And Luciano, I'm sorry, but you had such a lovely quote here. I'm using you as the target, but it could have been targeted a number of other people. Luciano goes on to say, inconsistent information is obviously of no use to a decision maker. Now, whether it has zero information or an infinite amount of information, that doesn't really matter. Either one would make it pretty poor, right, for a decision maker. But my story of the two firemen is intended as a counterexample to the claim of uselessness of inconsistent information. So here's the story. Suppose you're awakened in your hotel room by a fire alarm. You open the door. You see three possible ways out: left, right, or straight. I'm going to give you two scenarios. Scenario one, you see two firemen as you walk out the door. One says the only safe route is to your left. The other says it's to your right. Those are contradictory statements, that you have contradictory information. So there's the scenario. You've got three ways. Third way straight ahead. You could go right, but there's a fireman saying, come this way, not the other way. You could go left. There's a fireman saying, this is the only way out. Don't try the other ways. Which way do you go? Now, here's scenario two. You find no one to give directions. You've got not inconsistent information. One says go left, the other says go right, but you have incomplete information. There you are, scenario two. Which scenario would you prefer? Would you prefer to have, the too little information or the too much information? And the obvious answer, I think, is a rational agent would prefer to be in scenario one. Contradictory information in this case is better than no information at all. And I'll go on to say more about that. Now, a more homey example. And the essence of the example of the two firemen can be duplicated over and over again. An instance very familiar to me goes something like this. My wife Sally and I are leaving the house. I reach in my pocket and I cannot find my car keys. I tell Sally I think they are in a jacket pocket in the closet. She tells me they are on the piano. Again, this is all useful information. I will use it in my search. but it's contradictory. Now, I like these homey examples, and even the one with the two firemen. They're very different than the kinds of inconsistencies that people have often used to motivate what's sometimes called paraconsistent logic, right, or tolerant logic. People tend to get more into issues having to do with, is the Russell set, right, a member of itself and not a member of itself, and things like that. But these are very, very homey examples. Now let's focus on the firemen and examine several ways out, the pun is intended, several ways out of the seeming strangeness of inconsistent information being useful. First, a few abbreviations. L, left is a way out. R, right is a way out. S, straight is a way out. And O, there's just one way out. So here's the first way out of the example, as it were, of the paradox. Say it's not an explicit contradiction, like L and not L, like go left and you don't go left. It's only a partial contradiction. L and O and R and O are only contraries, right? They can't both be true, though one could be false. Well, the response is an obvious one. Contraries are only a stronger form of contradiction. L and O and R and O entails both L and not L. L and O entails L, obviously. R and O says right and it's only a way out. That entails, that not L, right? L is not a way out. So that doesn't get us any place. I put this one here maybe just to start with an easy thing, but because I've actually had people point this out to me, right? That they have this sense that, no, there's really something wrong here. That's not a contradiction. Those are contraries, but contraries are just a stronger form of contradiction, so that doesn't get us out. Second way out. The firemen make separate statements contradicting each other. There's no contradiction until I can join them. So we reject adjunction rule. This is something Jaskowski did in something called discussive logic. Normally you say if you have A, the proposition A, and the proposition B, you can form the proposition A and B, right? And infer that from A and B. Jaskowski says no, doesn't always happen. Well, my second response then is it's important to consider the two statements together. And if not, it's not conjunction, then I don't know what conjunction means. If I had reason to believe one more than the other, I might just disregard that other. But in the situation I described, I have equal reason to believe each. Slides. So one fireman says left and there's only one way out. The other one says right and there's only one way out. But suppose the first fireman then says, we can't both be right, but I'm certain one of us is right. It makes perfect sense, retreating to what David Makeson described to me as using their disjunction as a fallback reading or integration of the conflicting inputs. Now, I think there's a real point to this, but what I'm going to say, and perhaps too briefly, is yes, but now give me the theory that arrives at that conclusion. And I think what's needed is a very good and useful theory as to how to deal with inconsistent information when it's very pervasive. If all you know is something about what the fireman said, right, it might be fairly easy to get to a fallback position. But if you've got some backdrop of inconsistent information, then it's not so easy to get to a fallback position. And I'm not sure if I'll make that clear enough or not, but I'll try. Now, Makinson is, of course, famous for the AGM, the Alcheron Gardenfleury Makinson theory of belief revision. The key idea is that one believes P and then learns that not P, that one retreats to a consistent set of beliefs that includes not P, and hence excludes or throws away P. Makinson's response to the two firemen is in the same spirit. What he's basically saying is the two firemen are contradicting each other, so let's find a sort of maximally consistent theory, right, that accommodates the two. And that's the theory will include essentially that either this way and it's the only way out, or that way and it's the only way out. It's a disjunction. So my third response, and I've already hinted at that, is suppose, though, that there's what Carl Hewitt has called a pervasively inconsistent background. Then unless one is going to fix everything at once, there is no consistent set of beliefs to drop back to. To be a bit precise about this, and a bit humorous, I hope, let's suppose that you're a dialethist. A dialethist, raise your hands. How many of you know what a dialethist is? Okay, the rest of you should go Google and use Wikipedia or something, but a dialethist is a person who believes there are true contradictions. The Russell set, for example, might be a member of itself and not a member of itself, and we've discovered something very important when we figure that out, right? So I will tell you, swear that I am not and have never been a dialethist. I am a person who has worked on paraconsistent logics. We call them relevance logics, a special type I work on. And contradictions don't imply everything in those logics. But that does not mean I believe in true contradictions, right? I just believe that we often deal with very inconsistent information. And the World Wide Web would be one of the best examples of that. So imagine that you're a dialethist, like Graham Priest, who supposes there are true contradictions, and you were sitting in your room reflecting on the truth and beauty of the Russell paradox. Or suppose you're a mere computer scientist reflecting on how the World Wide Web has made you a cyborg by extending your system of belief. So you've replaced recall, memory recall, right, with search, right? That's how you get your knowledge, that's your whole belief system, is the web. Now, I do not disagree with Makinson. I've hinted at that already. I just think we have to somehow extend belief revision to accommodate pervasively inconsistent environments. Relevance logic could be a key component. Note that all the entailments so far mentioned in this talk are relevant implications within Anderson and Belknap's system of first-degree relevant entailments. Real trouble would raise its head if we allowed the irrelevant implication, sometimes called explosion, which says that from a contradiction, A and not A, anything whatsoever, B, would follow, right? Because then your belief system, viewed as a theory anyway, would contain all kinds of wonderful propositions. And when you're trying to get the minimally consistent set, right, you might have to consider putting some of those in too. I'm going to win it really big on the stock market today. I'd like to keep that one, right? So you've got to be very careful with using classical logic anyway. So let's leave this topic for another day, though, and get back to our two firemen. A new scenario, 1 prime. It's the same as scenario 1, the two firemen, but you can clearly see that you cannot safely go straight ahead. There are only two options now for you, left or right. Now it might seem that there is no reason to have a preference between scenarios 1 prime and 2. Remember, 2 was no information, so you're in this circumstance. One fireman's telling you, go this way, the other fireman's telling you go that way, but there's a fire straight ahead. You're not going to go straight, right? So what do you do? But wait, they still agree that there's a way out. So I can risk running left or right as opposed to staying in my room and preparing for my death, right? So I am still getting useful information, even in this highly inconsistent situation. Oops, went back again. the two firemen at least agree there's a way out. I can see it's not straight ahead. So I flip a coin or whatever, take whichever fireman looks the most authoritative or whatever, and I go left or right. Okay. Suppose a third fireman now shows up and points right, saying that this is the only safe way to go. Now I have some reason to run right, because I have two firemen, right? Both agreeing on running right, so maybe that's what I should do. I think that's the rational way to interpret it. Now, let's look at the World Wide Web a moment, better than nothing. Suppose you want to find an answer to a certain yes-no question on the World Wide Web. Which of the following scenarios do you prefer? A, you Google and get no relevant response. I'm ruling out the advertisements that pop up. I was Googling quantum computer once, and over on the right-hand side, something popped up. Do you want to buy a quantum computer? And I decided I probably wouldn't go that way. So you Google and get no relevant response, or you Google and you get multiple conflicting responses. Which would you prefer? I think, again, sorry, I keep going back and forth here. I think you would prefer to get the multiple conflicting responses. At least you know there's some interest in the area, and maybe you can sort it out a bit. Perhaps such investigations will sort things out so that you have in your mind at least a definite answer as to a yes or a no. But in a worst case, where you do not have the mind or time to do that, at least you might assign a value, and I'm sorry, I shouldn't have anticipated here, assign a value to what I'm going to call the opinion tetrahedron. That refers to my earlier work, and you'll see that at the end of the talk, if only based on your gut reaction. I expect you would prefer to be in scenario B. In this circumstance, you can at least try to sort the situation out. I'm a little jumbled here, sorry. You can count, for example, the number of opinions on either side. Like you had two firemen telling you to go right and only one telling you to go left. You can somehow assess the credentials, the authority, the motives of the sources on either side. You can look at the arguments, if any, provided by the sources. You can try to find cited facts, try to reproduce cited experiments, etc. Contradictory information can be helpful rather than having no information at all. It's worth emphasizing that the utility of contradictions is due not just to their content, but also to their pragmatic context. Some of the tools described on the previous slide might be taken as logical fallacies. For example, counting the number of sources can be interpreted as an argument from repetition, as in 50 million Frenchmen can't be wrong. That's a popular song from the 20s. Anatole France responded, if 50 million people say a foolish thing, it is still a foolish thing. But the aim here is not to prove P by the number of sources that say it, but rather to take a vote, determine the subjective likelihood that P. An improvement would be to check for duplications, one source merely repeating another source, to have trust weightings based on reliability, expertise, honesty, lack of bias, etc. Now a quick overview of the formal background from my previous talk. There's something called subjective logic that was developed by Auden Yosang, and I've just put up a slide there so you can see what it says in Wikipedia about it. It's viewed by him as a kind of probabilistic logic. It can be used for modeling trust networks. He's done a lot on trust networks, trying to fill out the kinds of things I was talking about in terms of authority, reliability, and so on. And for analyzing Bayesian networks. And in his view, arguments in subjective logic are subjective opinions about propositions. I'm not going to go into the more technical things, but opinions, these are also related to the belief functions of Dempster-Schaefer belief theory. And it's funny, I was talking to Teddy and someone else was it last night? Or no, it was just this morning, about how probability has kind of crept its way into philosophy. It used to be that the only logic talked about in philosophy departments was deductive logic, but now it tends more and more to be subjective logic. And we were thinking that the Dempster-Schaeffer theorem was one of the key ingredients in that invasion, if I could call it that. Yosang says a fundamental aspect of the human condition is that nobody can ever determine with absolute certainty whether a proposition about the world is true or false. In addition, whenever the truth of a proposition is expressed, it's always done by an individual, can never be considered to represent a general and objective belief. Well, I'm not sure about every proposition, but certainly many, many, many are such that we do not have absolute certainty. And what Yosang did is he introduced this opinion triangle, as he called it. And there are these three vertices. To the left, you have disbelief. And to the right, you have belief. And up at the top, you have uncertainty. And he introduces what are called the Berry coordinates. So you have here 0, and you have here 1, and that's, you measure along that, and you get a degree of disbelief from 0 to 1. Or you start here and you go this way and you get the measure the degree of belief from 0 to 1. Or you start here, get from uncertainty all the way up to, uncertainty all the way up to 1, and you get the 0 uncertainty is here. And so here you get the sort of ordinary thing that would take you from disbelief to belief with no uncertainty. But the more interesting thing is what happens when you use these Berry coordinates. And you can assign any proposition a triple. So here we've got point omega as 0.7, 0.1, and 0.2, which means basically if I'm measuring belief, I'm coming down up, just counting 0, 1, 2, 3, 4, 5, 6, 7. I get a degree of 7 for belief. I want disbelief. I'm starting here, and I count just 1, so I get a degree 1 of disbelief by projection. And then 0.2, I start here with 0, and I come up here, 0.2 uncertainty. Now, again, I project it to get 0.2. So there's a way of assigning, a very interesting way, 3 degrees, a degree of belief, a degree of disbelief, and a degree of uncertainty. And Yosang does a lot of work with this, and I'm not going to represent it here, but I do want to jump to what's sometimes called the Belknap-Dunn four-valued logic, and that, instead of having the usual truth and false, has actually 4 values. You've got subsets of TF, T for true, F for false. So you can have just singleton T, that's true, singleton F, that's false. You can have empty set, that's neither, right? And then, perhaps a little more surprising, you can have both T and F, that's both. So you can imagine looking at a database, unstructured database like the World Wide Web, and assigning propositions one of these 4 values, right, depending on whether you find information that's definitive, that's not definitive, definitively true, definitively false, or maybe conflicting information, you just can't tell, or maybe nothing at all. Though, as I pointed out, that gets rarer and rarer with the use of advertisements. So what I want to do is to embed this 4-valued logic, as it were, into something similar to what Yosang had about the opinion triangle. And if I had more time, I would show you how you could embed a usual three-valued logic into the opinion triangle, but I'm going to jump ahead and show how the four-valued logic can be embedded in an opinion tetrahedron. Sorry, oops. So, what I suggest is that there are two kinds of uncertainty. Yosang had just one kind of uncertainty. There's uncertainty where you just don't have the information, you're ignorant, and there's uncertainty where you have conflicting information, right? You're in a contradictory situation. So we could have two opinion triangles, as it were, with two kinds of uncertainty. Uncertainty meaning neither, and uncertainty meaning both. So and then of course I'm equating disbelief, absolute disbelief, with falsity, and absolute belief with truth. And so we have these two opinion triangles we could create. But obviously we should try to combine them, and that's what I do. If I drop a line down here, and this is one of those sort of optical illusion type things, right? Somebody should pop out at you now. You should see a tetrahedron, a four-sided object. And then what we should do is visualize this as an opinion tetrahedron, where we can put points inside the tetrahedron to represent degrees of belief, disbelief, uncertainty in the sense of ignorance, and uncertainty in the sense of conflict. And that's what we do. We establish coordinates by dropping altitudes from each vertex to the center of the opposite side. By convention, assign each the length 1, and they intersect at 0.25 or whatever information that's worth. And then a point, BDUC, as I've already said, is to be understood as representing a degree of belief, a degree of disbelief, a degree of uncertainty, and a degree of contradiction. And those are all values between 0 and 1. And it turns out that if you define and or and not in the obvious way, that you can embed that four-valued matrix of Belknap and Dunn into this opinion tetrahedron, where, of course, well, let me go back. N would end up there, F there, T there, and B there, of course. So that would represent the empty set when you have no truth values. That would represent the set when you have too much truth values, or you have both T and F. That would be when you have just singleton T. That would be when you have singleton F. I'm sorry for running over this quickly. I guess in a way I'm just showing off. There's a lot of stuff here that I could go into more deeply. And I think I will just end there. Thank you. Okay. Yeah. No, I think it's right here would be okay.
Okay, Mike, great talk. And I just wonder whether you have considered to use information theory to explain your two Firemen example, which probably could give a very relatively straightforward explanation, because by giving the two contradict instructions by the two firemen, actually the entropy in this particular case will reduce from 1.5 bits to 1 bit. So for those people not familiar with the information theory, less the quantity of entropy means the more certain information. And in some way, Luciana was partially correct, and because it's dependent on the number of passes you have. If you only have 2 passes as the optional passes, in this case, the entropy will remain same as a 1 bit before the instruction or after instruction. So Louisiana is correct in the sense in this case the zero amount of reduction, but in your case the 0.5 reduction. The more passes you have, if you have 4 passes, you will reduce from 2 bits to 1 bit. So the further the number of passes you have optional, then so in many ways you are correct. Louisiana not 100% incorrect in my view. So.
I'll be honest, I did not understand all of that, and part of it was just from a point of view of sound, and part of it was the point of view of the content. But the quick answer is yes and no. I have worked in some ways on the information theory, right, of the 4 values, as it were, but not in a deep enough way, I think. And you've suggested some things. We should talk. And that I should probably pursue.
Robinson, I'm intrigued by your opinion tetrahedron. Have you considered bringing in the theory of fuzzy sets into this? The notion of a fuzzy decision rule or fuzzy sets? It gets away from the bivalent yes, no, and talks about degrees. So it's notions of imprecision rather than uncertainty. But there's a whole theory of fuzzy sets and fuzzy decision theory that seems to me would fit very nicely into the framework you're setting up.
Well, notion of imprecision, of course, is a kind of uncertainty, and people have worked on that. I mean, developed logics, so-called fuzzy logics, right? Using values between 0 and 1 or something like that. And I guess you could view what I'm looking at as incorporating that in a way. But in a slower version of the talk, it would have gone through 3-valued logics first. But also, there are 2 kinds of imprecision, as it were, then. One would be where you sort of want to have both, and the others, where you want to have neither. And I suppose one could work that out. I just really haven't thought too hard about it.
That would be a multi-dimensional fuzzy logic, yes.
Sorry, Paul?
That would be a fuzzy logic, but multi-dimensional. So
Multi-dimensional fuzzy logic. Yeah, I suppose that might sell. Thanks.
I had a question, maybe this is more of a general question, but about multi-valued extensions of logic like this. In Jaynes, there's this discussion of the Cox theorems behind Bayesian, the assignment of probabilities as degrees of belief. And those theorems say that the probability system is really the only one that satisfies certain axioms of consistency and so forth. I'm just curious, when you depart in these directions from the standard probability theory, which of those axioms are you willing to give up? Well, if you generalize to these 3 and 4 valued logics, you clearly are giving up the Cox theorems, right? Which of the premises of the Cox theorems are you willing to?
I'm not sure I can answer that off the top of my head. I do intend this, incidentally, as kind of a approach to subjective probability. I mean, these degrees of belief, disbelief, ignorance, and in 2 senses, right, can all be viewed as, in a context of subjective probabilities. And when I look at the way you define the logical connectives, et cetera, I make use of that. But no, I can't respond off the top of my head. I don't know enough to tell you which one of the Cox theorems premises I would give up. I do have a copy of Jane. I think it's a wonderful, wonderful book, and I will certainly look at it when I go home. Thanks. Yeah, no, I get that. What was being said is that you've got two situations, right? Maybe you're searching on the web, maybe you're trying to figure out whether to run from your room or not, which way. Maybe you're trying to find your car keys. And in one situation, you have no information. The others, you have conflicting information. I wanted to suggest that having the conflicting information is better because you can actually use it sometimes. But if not directly, at least indirectly, because you can then try to sort it out, right? And this leads me to want to talk about what I see as the big picture. And the big picture goes something like this. There are two kinds of ways that you can be using information. One is kind of statically. I've got the information. One fireman says this way, the other fireman says that way. I don't have time to question them. I don't have time to search the web about their credentials, etc. You know, one has a blue uniform, the other one has a red uniform. I can't Google and say, blue uniform, you know, fireman, you know, and say, aha, they're always right. It says, ah, no, I can't do that, just don't have time. So if you're thinking about, and I have a former student, Raimundo Morado, now at UNAM in Mexico, he wrote a dissertation on what he called fault-tolerant reasoning. And some of what I'm saying I'm borrowing from him. And the idea is that you need sometimes fault tolerance in the sense that you need something to protect you right now. And maybe, you know, the thing to do would be to get some sort of a fireman suit or something, right? But I don't have that. So the best thing I can do right now without updating information is to just make a decision, go left, go right. But a better thing to do, clearly, if I had the time, would be to update my information. And that's where you get into this sort of revision theory stuff I was beginning to talk about. And what I really would like to see developed, Raimundo made a good start, but I don't mean to criticize it. It was a pioneering start, but I don't think it was enough. Is a system for revising beliefs, revising theories, as I said, in a pervasively inconsistent context. And that would involve two things. One would be the practicality, right, of how you might choose certain information over other information as something you need to include. But a much more important thing would be how you can do that in the context of what I'm calling pervasively inconsistent information. Because the standard belief revision type thing says, let's get back to a consistent belief system. You know, I used to believe P, now I believe not P. I'm going to get back to a sort of maximally consistent belief system that includes not P and excludes P. But if everything around you is inconsistent, you can't easily do that. It's like needing to not just put out the fire, but put out the fires all over the world. You know, it's a superhuman task. And so the idea, you know, that because I find a little bit of inconsistent information on the web, I'm going to fix the whole web, you know, that's impossible, right? I might be able to fix that one little bit of it, but fix the whole web, every little contradiction there is, you know, about from truthers and so on, right? I mean, you know, that's impossible. So I think you raise a very, you know, interesting set of questions. In fact, it's what I really think of as the big picture that I want to deal with.
Yes, quick comment and a question about from the target. The paradox that we find in Carnap and Bar Hillel is that the more unlikely a piece of information is, the more informative it becomes. Yeah. And then they got stuck with the idea that the most unlikely is the impossible one, which is P and not P. So that's the background. So when I said that P and no P is useless to anybody, that's what I refer to. I therefore completely agree with your analysis, because you're not dealing with that. You're dealing with something slightly different. Interesting, but different. The difference here is that the two firemen could be both right, for example. I could go left and right and be safe. The fact that I cannot go both right and left simultaneously is a pragmatic constraint, but it's not constraint on the truthfulness of what they are saying. I might be safe on the left and I might be safe on the right. So it doesn't matter. I go left or right. That's okay. It would be different if I meet one fireman and he says, Luciano, if you want to be safe, go left and do not go left. Am I better off?
So, yeah, we could talk more about this, Luciano. But my quick response is that you've left out the fact that they're also saying, and there's one way out. Now, if the one fireman says, go left and don't go left, and there's one way out, I think maybe you are better off. You've got that information that there's at least one way out. And especially when you see the fire in front of you, you don't go straight. But I don't know. What would you say to that? Okay. Okay.
So, your focus in this work has been on that when you get more information, if you get the contradictions in there, that we don't have to throw the baby out with the bathwater, so to speak, that there's information to be had. More information can be good. It sort of raised in my mind, though, a dual question where even if all the information is true, there's all kinds of studies that show, you know, like in examining user interfaces to diagnostic software for doctors and stuff, that if you hand them up to, I think 4 is the optimal, that if they get more than 4 pieces of information, they start to give worse diagnoses, even though they have more true information. So everything they know is true, but adding more makes things worse. And I wonder if there's some sort of dual to what you're doing in that. Oh, we'll talk over lunch. Well, I guess I was thinking that your work is all sort of as you move to a point where something might have to be false, that doesn't matter. You're adding information and that can be useful. But I guess I was wondering about cases where even though a dual result, where even though everything is true, adding more information still makes it worse.
Yeah, that could certainly happen. That's what I thought you were saying. From a practical point of view, there's no doubt that can be the case. In fact, we maybe saw an example of that where I didn't understand your long question, but I understood the shorter one. Yeah, right. No, that certainly is true. And I don't know. I mean, you know, now we're talking about the value of information. And part of the value of information has to do not with the value of information, each piece separately, but the value of it taken as a whole. And it's certainly clear that, I'll use a crude example, right? When you're buying stuff at the grocery, right? Getting the right amount is incredibly important, right? If somebody started dumping, you know, all those foods, you know, on your front lawn, right, with dump trucks, you know, that would not be very useful. And you can't consume that. And I think that certainly one of the key things that we face as educators is to how you package information in digestible quantities, right? And I think, quite frankly, I have a very negative view about 24/7 newscasting. I think when you see something that's absolutely horrific, like, you know, I almost hate to mention it, but the bombing of the Boston Marathon, once they start covering it 24/7, you're getting all kinds of information that is not terribly helpful, I think. And some of it's not even true. I know Luciano would say all information has to be true. We differ on that. But however you put it, I mean, there's just an awful lot of unhelpful information going out there. And I think it confuses people. So no, I think there's definitely a point there. Thank you.